All right, so today and tomorrow, these two sections are related to each other. We're going to be looking at complex numbers, but we're going to get away from writing them like 2 plus 3i. We're going to write them in a different way that helps us to do certain things easier. Okay, there's nothing wrong with writing a complex number as a real part and an imaginary part, like that, but it does kind of limit how fast you can do certain calculations. It's fine for some things, but not for everything. We're going to start to get into some more basic arithmetic stuff, but with complex numbers. So we're going to look at how we can multiply and divide complex numbers faster, and then how can we raise complex numbers to powers, and how can we reverse that by taking roots. So we're going to look at multiplication, division, powers, and roots over the next 2 days. All right, so just a reminder that a complex number is written generally in that's called standard form, real part plus imaginary part. So there's an example of a complex number. 2 is the real part, 3 is the imaginary part. Okay, well, another way to represent it besides writing like 2 plus 3i is you can actually graph it. Okay, there's a way you can graph 2 plus 3i, and it's just as easy as graphing the point 2 comma 3. In fact, if you can graph the point 2 comma 3, that's really the answer to that problem. So graphing something that's in standard form, okay, a plus bi, is just like graphing the point a comma b. Somebody remind me again, what's a? What does a represent in this complex number? That's the real part. And what about b? That's the imaginary. Now, when you write something as a coordinate, the first letter, we don't normally use a. When you first learn about it, what's the letter that you use? Yeah, so this is like x, and b is like y. So what that means is, instead of having an x-axis, you have a real axis. And instead of having a y-axis, what's going to take the place of that? The imaginary axis. Okay, so when you graph in the complex plane, the real axis is horizontal because x is horizontal, and x is what's representing the real part. And y, okay, that's going to be replaced by your imaginary axis. Okay, and this is called the complex plane. Not something you can do on the graphing calculator the way it is. Maybe there's a program you could download to do it, but just the calculator itself cannot graph complex numbers. So any question on the complex plane? All right, so I'm going to give you some imaginary numbers in standard form, and all we're going to do is graph them. Okay, so this part, it's pretty straightforward. I'm going to label this real axis, imaginary axis, instead of x and y. And let's graph a few complex numbers. Okay, anyone think they can tell me, starting from the origin, how I graph the point -4 minus 2i? Yeah?
Go 4 to the left and 2 down.
Okay, so there's the point -4 minus 2i. Yep. You just want to make sure you don't switch the real and imaginary axis. Real is horizontal, imaginary vertical. How about -2 plus 3i? Luke?
Go left 2.
Yep.
And then up 3.
Up 3, yeah. Just like graphing the point -2 comma 3. Okay. How about 5i? What's the real part of that number? 0. Yeah, there is no real part. So How are you going to graph that? Go up 5. All right? So we got 5i, and then the last one, 6. What's the imaginary part there? 0. So there's no imaginary part, which means you're not going to go up and down. So how would you graph 6? You just go to the right 6. And that's all you have to do to graph a number in the complex plane. All right, so any questions on graphing? So that part's pretty straightforward. All right, so absolute value of a complex number. What does that mean? Like, when we say absolute value, how do you define that? Forget complex number, just absolute value in general.
The number of places away from 0, so it's always going to be a positive number.
Yeah, it's always positive, and it's measured as the distance from 0. So, if we're looking at these complex numbers, and look at this plane, I don't really have 0 as a starting point. What do you call the starting point on a plane? The origin. So if you want to know the absolute value of any of these numbers, all you have to do is pick a point and measure the distance, not to 0, but we call it the origin. Right? Measure the distance to the origin. Now, in some cases, that's pretty easy to measure. Like for this one, it's just 6 units. You can just count it. 5i is just 5 units. You can count it because it's on an axis. But what makes that a little harder to find that distance? Yeah, because the line is at an angle. So what do you think we could do? How would you use trig to figure out the length of that line segment? Yep, you can make a triangle out of it. It could go like this. It could go like that.
And then you can count the number of units, right? So that one would be 4 units and then 2 units, right?
Yeah.
And you do that for 0.
Yeah. Once you draw your triangle, all you have to do is basically square the real part, square the imaginary part. Square the 4, you get 16. Square the negative 2, you get 4. Add them up and take the square root. So you're just doing the Pythagorean Theorem. Good, so here's the same picture I drew, just this is in quadrant 1 instead of the quadrant I was in before. So to find the absolute value of a complex number, square the real part, square the imaginary part, add them up, and then take the square root. So it's just the Pythagorean Theorem. Okay, so far I haven't done anything that was in the title. Okay, we haven't talked about trig form of complex numbers. This is graphing in standard form. This is finding absolute value in standard form. Okay, so we're still working with standard form. Questions on the formula for absolute value? Okay. So let's find the absolute value of that number. If you want to sketch it and make the triangle, you can. Or just use the formula. Just plug A and B into the formula. That's all you have to do. Okay, so what's A in this case? 3. And what do I do with it? Square it. What's B? 4. And what am I going to do with that? What do I do with those two things? Add them up and take the square root. 3 squared is 9. 4 squared is 16. What's 9 and 16? 25. So what's the absolute value of 3 plus 4i? I. And as Luke said, finding the absolute value should always be a positive number because it's measuring the distance from the origin.
Is that a Pythagorean triple, Mr. Hager?
Yes. Yes, it is.
Learning something.
You're learning something. No decimals, it's a Pythagorean triple. A lot of times we don't get it to come out to a nice answer. If you don't, just round it to 2 decimal places if they ask you to round it. Or let's say this was the final answer. What would you do with that if that was the result after that step?
Leave it as simplified.
You would simplify that to what? Square root of 4 times square root of 5. Yep. And what's the square root of 4? 2. So if you get a root you can reduce, make sure you always reduce it like that.
Square root of a squared plus b squared.
The formula again?
Yeah.
Yep. Okay. So any questions on how we got that? Okay. So that's pretty straightforward. Okay. So from here till the end of class tomorrow, we're going to start looking at how we can write complex numbers a different way. Okay, trig form. Standard form is great to find absolute value, very quick. If you have to add complex numbers or subtract them, standard form is fine. If you have to graph them, standard form is fine. But more complicated things like multiplication, division, raising to a power, and taking roots, standard form is not the best way to do it. All right, so let's take a look at this diagram. Okay, what I've done in that diagram is basically I graphed that point, x plus iy, that's a complex number, and I just taught you earlier how to graph it. X is the real axis, that's your horizontal, and y is the imaginary, that's your vertical. Now we don't know necessarily that we're in quadrant 1, but it's easiest if I do the diagram in quadrant 1. Okay, when we want to write a number in trig form, there's 2 things we need to figure out. The first thing we have to do is figure out this distance, okay, this hypotenuse. And I want you to think of that hypotenuse like that. What did I just turn that hypotenuse into? It's the radius. So that's why we're going to call the hypotenuse r. Now, this is very similar to doing something we just did. What is the distance from the point to the origin?
Y squared plus x squared.
Yeah, it's the absolute value, basically. It's the Pythagorean Theorem. We just did that. So when we have to calculate r, we should already know how to do that from the last page. So r is one thing you need to find. And the next thing you need is that angle. It's the angle from the horizontal axis to that radius. We call that angle theta. Okay.
The opposite over hypotenuse or the adjacent over hypotenuse, right? The sine or the cosine?
Yeah, we're going to use sine and cosine to kind of come up with a formula, something we could replace x with, because in trig form, x doesn't exist. The only thing that exists in trig form is r and a theta. Okay? And also in trig form, y doesn't exist. Okay? X and y, that's standard form. Okay? Trig form, x's and y's are replaced with r's and thetas. So let's start with doing the cosine of theta. Well, in this triangle, what would the cosine of theta equal? Yep, it would be x over r. And now, I'd like to get x by itself. So how would you move that r to the other side? And multiply, Nick, was that what you were going to say? Yeah, you multiply both sides by r, and you get r cosine theta equals x. Now you have a formula that you can plug in, and it'll get rid of the x. It'll turn the x into r cosine theta. Okay, now we also need a formula to get rid of y. What trig function could I use, do you think, to replace y?
Y over r, right? So that would be
Yeah, what would y over r be? Which trig function?
cosine.
Not cosine, that's x over r. Sine. Sine is opposite over hypotenuse. So what Luke just said, y over r. All right, so what would y equal? R sine theta. Any question on why y is r sine theta? It just comes from setting up that right triangle and then multiplying, I didn't write this out, multiplying both sides by r. Okay. And now we can take this and plug it in for which letter? Y. If you do what those two arrows are saying, that's the trig form of a complex number. It won't have an x and a y in it. It will have an r and a theta. So what would happen is replace x with r cosine theta. That's what I did right there. And replace y with r sine theta. And that's what I did right there. So there's x, there's y. Those two things I underlined in blue, what do they both have in common in front of them? An r. And when two things have something in common, what can you do with the thing that they have in common? You can factor it out. So what we do is we factor out the r, put it in front, put a set of parentheses. And you can double check that we did it right by multiplying it back out. R cosine theta, and then I r sine theta. Okay, so what's in that box? That's the trig form of a complex number. Okay, so if they ask you to write a complex number in trig form, a final answer would look something like this. Let's say r was 2 and theta was 10 degrees. It would be 2 cosine 10 degrees plus I sine 10 degrees. That's a final answer. That's what it looks like. You don't do this out. You don't have to distribute. You just leave it just like that. So in order to find it, though, what are the two things that you need to know that are in that box?
R.
You have to be able to find r, which is the distance from the point to the center. So it's the absolute value. And you need to know how to find theta. That's what we just said. So r is the distance from the origin, and theta is the angle with the positive x-axis. Okay, so we know the format, okay, what our answer is supposed to look like. We know what each thing in the answer is. Okay, we know what r is. We know what theta is. Now we're going to look at how do you find each one of those. So any questions on what r represents or what theta represents first? No? Okay, so let's start off with r. Okay, that's the easier one. All right, so let's say that's a point that they give me. Pretend that that's a complex number, and we've graphed it, and I want to convert it to polar. That's the first thing I need to find. Okay. That's r, the distance from that point to the origin. Now, what can I do in that diagram to turn that into a shape that I could work with? Yeah, we're going to make a triangle out of it. And the way we'll make a triangle is, I think my board is a little off. We're going to draw a line straight down from the point. And you don't really need to draw this line. It's already there. Okay, how long is this bottom side? Yeah, this is x. It's how far you go from here to here. And then how far up do you go? Y. Okay, so to find R, what would you do in that triangle? Yeah, you just use Pythagorean theorem. Okay, which, I'm going to write this down on the next page, but the idea is to find R, use Pythagorean theorem. X squared plus y squared equals R squared. Okay, I'll write that. You can write it now, or I'll write it down in a minute. Now, the other thing I have to do is find theta. Based on knowing x and y, okay, what's the name of the side that's across from theta? I mean, it's represented as y, but what's its name relative to theta?
Or it's
This is opposite. What's x? Adjacent. So what trig function involves opposite and adjacent? Tangent. So the tangent of theta would equal, what would go on top? Y over x. Now that's not theta. That's the tangent of theta. So to get theta by itself, what would you have to do on each side? The inverse tangent. And I'm going to write this down on the next page, a little more organized as well. Okay, but that's basically how you find your angle. You use inverse tangent. You find R using Pythagorean theorem. Okay, that's exactly the formula we just came up with on the other page. Now, does anybody remember when you do inverse tangent on the calculator and hit enter? It's always between two certain numbers. It's negative this number to positive this number. Not 1 and negative 1. These are angles. Anybody remember? Like for inverse cosine, you always get an answer between 0 and 180 degrees. For inverse tangent, you always get an answer between negative this and positive this.
It's -1 and +1, right?
No, that's what Fred said. It's not -1 to 1. We're thinking of like an angle.
Negative 3 cents to the positive 60.
90 to 90? Negative 90 to 90. Yeah. Anytime you use inverse tangent, the answer is always between negative 90 and 90. So here's negative 90. Here's positive 90. If you go from negative 90 to positive 90, what two quadrants am I in? 1 and 4. So if all you do is inverse tangent of y over x, you could never get an answer in quadrants 2 or 3. But when you graph a complex number, could it end up in quadrants 2 or 3? Yeah. Graph the point -2, 4. That's in quadrant 2. So we have to make a small adjustment to our formula. If we're in quadrants 2 or 3, and you're working in radians, you have to do pi plus inverse tangent y over x. If you're working in degrees, it's 180 plus inverse tangent y over x. Okay, so to find r, use Pythagorean theorem. To find theta, it's inverse tangent y over x if you're in quadrants 1 and 4, or 180 plus inverse tangent y over x if you're in quadrants 2 or 3. But now this still doesn't cover everything that could happen with your angles. It covers if you're in quadrants 1, 2, 3, or 4. Where else could you be? Yep. Yeah, you could be on an axis. Okay? And the problem with this formula working if you're on an axis, pretend we are on a unit circle. What's the coordinate of the point that's at the top? Well, it's 90 degrees, but the coordinate is 0, 1. What's the x value here? And the y value? 1. Well, if x is 0, and you tried to plug it in to this fraction, or the one below it, what would happen? Yeah, you'd get no solution. This formula doesn't work on an axis, and I didn't say it did. It only works in quadrants 1 and 4, or quadrants 2 and 3. These formulas don't work if you're on an axis. So the other 4 possibilities you could have is being here, which is 90. What if you're here? Yep, it would be a coordinate like negative something, comma 0. Could be negative 1, negative 2. But what's the angle? 180. Now if you're here, this would be a coordinate like 0, comma negative something. And that would represent an angle of 270. And 360, or back at 0, that would be an angle that's something positive, comma 0. Okay, so those are the other 4 angles. We just have to know those 4. Okay, so if a point isn't on an axis, the angle is either 0, 90, 180, or 270. Okay, or radians, I have it written on the board. And those are the easiest angles to figure out because one part of the coordinate is always 0. Okay, so any questions on the idea of how you find r or how you find theta?
You don't know that.
It doesn't, yep. Okay, so this is important to know how to do because everything else we do that's based on working with complex numbers is going to rely on converting them to trig form. So when we start to do some problems, last couple problems today and problems tomorrow, this is the first step. Changing something like that to trig form. Then we can do something with it. Okay, but we've got to know how to change it to trig form first. So when we're changing to trig form, can somebody remind me, what are the 2 things we have to find?
Theta and r.
Yep, theta and r. And it doesn't matter which one you do first. They're totally separate. So on this one, do you want to do theta first, or do you want to do r first?
R.
Okay, we're going to do r first. R doesn't depend on the quadrant. You just use the Pythagorean Theorem. Doesn't matter what quadrant you're in. It's going to work out the same. So how would I plug that into my Pythagorean Theorem? If you need a picture, it would look something like this. Left 2, up 2. Okay, so how would I find R?
2 squared plus 2 squared under square root.
Square root. Yep, so 2 squared plus 2 squared, add them up, take the square root. So that's going to be the square root of 8. And this is one of those roots that you can reduce, like the square root of 20. What's the square root of 8 reduced to?
The square root of 2 times 2, right?
2 square roots of 2, yeah, because you could split it like this. 4 times 2 is 8, and the square root of 4 is 2. Okay, so that's half of it. That's our radius. And what's the other thing I need? Theta. Now, with theta, we have to be careful because we use a different formula depending on if you're in quadrant 1 or 4 or 2 and 3. What quadrant am I in this time? 2. So what's my formula for theta in quadrant 2? And let's do it in degrees.
Aren't you on an axis, so you can't, oh, and the point's on.
This point? No, that's right in a quadrant. So what's my formula for theta in quadrant 2 using degrees?
Is theta equals, are you using radians or using degrees?
Degrees.
Theta equals 180 plus the inverse tangent of y over x.
Of y over x. And yeah, in this case, that's x That's why. So it's 2 divided by negative 2. All right, so let's type that in. 180 plus, and I can save myself a little time, what's 2 divided by negative 2? So let's just type it in like that. Okay, so we get 135 degrees. Now, that's not the way we write the answer. We have the two things we need to write it. We just have to plug them into that formula. So write out exactly that formula. Just change r and theta to what we just solved for. Okay, so r is 2 square root of 2 cosine 135 plus I sine 135. That is the final answer. If you were to distribute out the 2 root 2, okay, and take the cosine of 135 and the sine of 135, you would change this exactly back to what we started with. Okay, so we don't want to change it back. So don't take the cosine of 135 and don't distribute anything out. Leave it just like that. Okay. Any questions on that one? All right, so the reason, and now we'll get into what we're going to use it for. The first two things we're going to look at are multiplying and dividing. These are the last two things for today. Raising things to powers and taking roots we'll look at tomorrow. So trig form makes multiplying and dividing with complex numbers super easy. But I want to remember how we had to do it if we don't have trig form. Okay, we've done this already before. Here's a complex number, 3 divided by 5 plus I. Does anybody remember how you would divide this the way we already know how? This is back using standard form. A lot of things you have to do. Yep. Yep. Find the conjugate of 5 plus I. And what do you do with the conjugate? Multiply it on the top and the bottom. What's the conjugate of 5 plus I? 5 minus I. Okay, now I need to distribute this out. 3 times 5 is 15. 3 times negative I minus 3I. Now in the bottom, I got 5 times 5. What happens to 5 times negative I? 5 times positive I. That cancels. What's a positive times a negative? Negative. I times I? It's I squared. So I still have 15 minus 3I on the top. What is I squared? Negative 1. So we have 25 minus negative 1 in the bottom. So we have 15 minus 3I. What's 25 minus negative 1? It becomes a plus 1. Yep. So it's 26. And finally, the last part would be to separate that into a real part, 15 over 26, and an imaginary part. And that's the answer if you want to divide two complex numbers in standard form. Okay, a lot of different things you have to remember. Okay, multiplying by the conjugate, and then foiling everything out. Combining like terms, changing I squareds to negative 1, and then splitting it into a real part and an imaginary part at the end. And this wasn't even as bad as it could be because the top number was just a 3 to distribute. It could have been like 3 plus I, and then you'd have to foil the top and the bottom. Okay, so that's the way we used to divide complex numbers. Okay? There's a lot better way. But any questions on what we just did there? All right, so now let's look at the better way. So the better way assumes that you have numbers in trig form. Okay, it assumes you already have given numbers in trig form. If they're not in trig form, is it worth the time to take a problem like this, change the top to trig form, change the bottom to trig form, and then do the shortcut I'm about to show you? I don't know. The payoff with writing things in trig form is more the kind of things we're going to do tomorrow. But if you are already given numbers in trig form, I'll show you a very fast way to multiply and divide. Okay, so we have two complex numbers. I'm just calling them Z1 and Z2. And Z1 and Z2 each have their own radius. I'm calling the radius for Z1 R1, calling the radius for Z2 R2. And Z1 and Z2 each have their own angle. They could be the same, they could be different, doesn't matter. The angle for Z1 is theta 1, the angle for Z2, theta 2. Okay, so I'm going to show you a shortcut for multiplying and dividing. If you want to multiply two complex numbers together that are in trig form, all you have to do is take the two radii, multiply them together, take the two angles, and add them up. That's it. Take the two radii and multiply them. Take the two angles and add them. This is going to take the place of all that foiling you would have to do. If you had two complex numbers like this, and I said to multiply them, you'd have to do 2 times 5 is 10, 2 times negative 8i, 5 times 3i, and then 3i times negative 8i. That'd be negative 24i squared. Change the I squared to negative 1, combine all the like terms. All that I just said is going to go away in trig form. Multiply the radii, add the angles, you're done. That's the whole problem. Now, the formula for division is very similar. It follows the same kind of pattern. When you divide, what do you think you would do with R1 and R2? You would divide them. R1 divided by R2. And what do you think you'd do with your angles? Yeah, you subtract them. So dividing two numbers and subtracting two numbers is going to take the place of everything that we just did in this problem right here. All of that. So you just have to divide two numbers, and I'm assuming that R2 is not 0, because you can't divide by 0. And subtracting two angles. It's going to be a much, much faster way to multiply and divide. All right, so in this problem, I'm giving you two complex numbers. They're not in polar, but I converted them to polar for you. One of these I think we already did, the 3 plus 4i. Or maybe it was the negative 2 plus 2i. Let me go back for a second. Oh, it was the negative 2 plus 2i. So we got the radius is 2 root 2. And I did the angle in degrees. In this problem, I just changed the angle to radians. It's 2.36 radians. So you've already converted Z2 to trig form in an earlier problem. Z1, I don't think we did. Okay, but I converted it to polar for you. We found the radius. It's a 3, 4, 5 right triangle. And I found the angle in radians. Okay, so I want to take and multiply Z1 and Z2, and then divide Z1 and Z2. Okay, let's start with multiplication. If I want to multiply Z1 and Z2, what do I do with my two radii? multiply them. So what's 5 times 2 square root of 2? 10 square root of 2. And if I'm multiplying, what do I do with my two angles? Add them. So just take 0.93 plus 2.36, you get 3.29. That's it. That's the whole problem. That's the answer of how you multiply Z1 and Z2 in trig form. Okay, trig form is also known as polar form. So if you hear me say polar form, trig form, same thing. Okay, now, if I was going to divide Z1 by Z2, all right. So, as I just said, if we were going to divide Z1 by Z2 the old way, okay, if you were going to divide 3 plus 4i by negative 2 plus 2i, first step, find the conjugate of what's in the bottom. Multiply it on the top, and then multiply it in the bottom. FOIL everything out. Combine all your like terms. Anywhere you get an I squared, change it to negative 1. And then when you're done, separate it into a real and imaginary part, just like I did right here. Now, we're going to get rid of everything I just said and do it in polar. What do you do with your radii when you're going to divide Z1 by Z2? Divide them. So take 5 and divide by 2 square roots of 2. I'm going to do it off to the side for a second, because that's what you get when you divide them. But what's wrong with that answer? Square root's in the bottom, so how do we fix it? Multiply by the square root. This is just arithmetic to fix the root being in the bottom. What do you get in the top? And what's 2 times the square root of 2 times the square root of 2? 4. Right? Square root of 2 times square root of 2 is 2 times another 2. Okay? So that's what you get when you divide. 5 square root 2 over 4 times, and what do I do with my angles? Subtract. 0.93 minus 2.36, negative 1.43. Okay, so there's a couple things we had to fix here. One, we had to do a little arithmetic because we got the root in the bottom. But that's basically it. That's our answer. That took the place of everything we just had to do in the previous problem. Now, the only thing that sometimes they might do is get rid of that negative, which is very simple to do. What did we say the difference is between taking cosine of an angle and cosine of the same angle with a negative? Anybody remember? We looked at this back, it's when we did the sum and difference identities last week. Difference between, say, cosine of 10, cosine negative 10. Nothing. There is no difference between taking the cosine of positive 10, look at that number, and taking the cosine of negative 10. It's exactly the same number. So what does that mean about this negative? On the negative 1.43. It doesn't matter, at least with cosine. Okay, so if you ever get a negative on cosine, okay, we've said this before, you don't need it. Now, what about the negative with sine? Can I get rid of it there? No, I can't get rid of it there, but look at the difference between sine of 10, 0.173, and sine of negative 10, negative 0.173. So what's the difference between those two? Sine of 10 and sine of negative 10. John? So here's the sine of 10. Here's the sine of negative 10. What's the difference between those two numbers?
Degree. Well, I mean, aren't they on opposite quadrants?
So what was the first number I got?
173.
0.173. And what was the second number? Yeah, so what's the difference between those two?
8 degrees.
Just comparing, like if you ask somebody like in second, maybe third grade, I don't know when they do this, but third grade.
One's positive, one's negative.
Yeah, the only difference is one's positive, one's negative. So the negative, you can't get rid of it, but what you can do is move the negative in front, just like it is in that number. You can put the negative in front. So what happens is it becomes this. So that's how you can very easily deal with a negative. If it's with cosine, just get rid of it. If it's with sine, you can just move it in front.
I think it's really imaginary.
What's that?
Is it get rid of the imaginary?
Oh, yeah, thanks. Keep the imaginary. Yeah. So that doesn't always happen. Okay, in the first one we did z1 times z2, we didn't get a negative with the angle, so we didn't have to think about it. So if it doesn't happen, don't worry about it. Just like if you don't get a root in the bottom, don't worry about it. You only have to worry about it if it happens. Okay? And this time it did. Okay, so what if I had something like this? 6 cosine negative 50 plus I sine negative 50. Can somebody tell me how I could rewrite that without any negatives?
6 cosine 50 minus I sine 50.
Yeah, 6 cosine 50. Don't forget your parenthesis on the by the 6 minus I sine 50. That's it. Negative with the cosine, get rid of it. Negative with the sine, move it in front of sine. Okay, and they might not even always do that. If you get a multiple choice question on a test and you see that as an answer, but you got what's above, I just want you to see they're the same thing. That's all. Okay, so when you multiply complex numbers in trig form, what do you do with R1 and R2? Multiply them. What do you do with theta 1 and theta 2? Add them. Okay. When you divide complex numbers, what do you do with R1 and R2? Divide them. What do you do with theta 1 and theta 2? Subtract them. So we just have to make sure we keep those straight. Multiplication, multiply the radii, add the angles. Division, divide the radii, subtract the angles. All right, so homework tonight, we'll cover everything we did. It's not all multiplying and dividing. Some of it's just the graphing and finding absolute value. Okay, so it's on 450. 1 through 3, 5, 8, 11 to 14, 17 to 20, 33, 34, and 37. Okay, so don't forget, again, those that are going on the field trip tomorrow, okay, I put up the homework at the beginning of class. It's section 8.4. We still have the test on Friday, so you are still responsible to make sure you watch the video or come see me for extra help to figure out that material before the test on Friday. Okay?